Recommendations depicted in this animation for pipe anchors and guides represent the minimum requirement for controlling pipelines which contain expansion joints and are intended to protect the expansion joint and pipe system from abuse and failure. Additional pipe supports are often required between the pipe guides in accordance with accepted piping practices. This animation typifies good practice in the use of a single expansion joint to absorb axial pipeline expansion. A single expansion joint is utilized between two main anchors. This expansion joint is normally located adjacent to one of the anchors. Note the closeness of the first alignment guide, the spacing between the first alignment guide and the second alignment guide, and the spacing of intermediate guides along the balance of the line. This animation typifies good practice in the use of two singles or one double expansion joint to absorb axial pipeline expansion. The addition of the intermediate anchor, which in conjunction with the two main anchors, divides the pipeline into individual expanding sections so that there is only one expansion joint between any two anchors. Note, as in the previous animation, the closeness of the first alignment guide to each expansion joint, the spacing between the first alignment guide and the second alignment guide, and the spacing of intermediate guides along the balance of each pipe section. This animation typifies good practice in the use of expansion joints to absorb axial expansion in a pipeline containing a reducer. The anchor at the reducer is a main anchor designed to absorb the difference in the thrusts of the expansion joints on each side of the reducer. Note, as in the previous animations, the closeness of the pipe guides. This animation typifies good practice in the use of expansion joints to absorb axial pipeline expansion in a pipeline with a branch connection. The anchor at the junction, which in this case is a T, is the main anchor designed to absorb the thrust from the expansion joint in the branch line. Note, as in the previous animations, the closeness of the pipe guides. This animation shows the application of a single expansion joint to a pipeline containing an offset. It should be noted that applications of this type are not usually recommended and will perform satisfactorily only within certain limits. As previously presented, the line is provided with main anchors at each end to absorb the pressure, movement loading, and guide friction. Where the line contains an offset, this load must first be transmitted through the offset leg, resulting in a moment on the piping. Where the line size is small and the offset is appreciable, or where the pressure and movement forces are relatively high, this configuration may result in overstressing or distortion of the piping and guides. This animation typifies good practice in the use of a pressure-balanced expansion joint to absorb axial pipeline expansion. The expansion joint is located at a change in direction of the piping and the elbow, and the end of the pipeline are secured by intermediate anchors. Since the pressure thrust is absorbed by the expansion joint itself, and only the forces required to deflect the expansion joint are imposed on the piping, a minimum of guiding is required. Frequently, directional guiding adjacent to the expansion joint, as shown, may suffice. In long, small diameter pipelines, an additional guiding may be necessary. This animation shows the use of an inline pressure-balanced expansion joint to absorb axial pipeline movements in a long straight piping run. By utilizing this arrangement, the two anchors shown are relieved of pressure loading. Therefore, the system needs only be intermediate anchors. Since the piping is relieved of compressive pressure loading, a minimum of guiding is required, primarily to direct the thermal expansion of the piping into the expansion joints in an axial direction. This animation typifies good practice in the use of a pressure-balanced expansion joint to absorb the thermal expansion of equipment such as turbines, pumps, compressors, etc. The primary function of the expansion joint is to minimize loading upon the equipment casing. Only an intermediate anchor is required at the change of piping direction, and if the expansion joint is located immediately adjacent to the machine, no guiding is required. Care should be taken to provide sufficient flexibility in both the flow bellows and the balancing bellows, so that the forces required to compress the expansion joint do not exceed loading limits for the equipment, as established by the equipment manufacturer.